Okay, so leading on from the mean, the mode and the median as our central tendencies, we are now looking at the interquartile range. This is a slightly more technical skill. We're going to look at the strengths and weaknesses of the data set that I have here because it's not the best data to use, but it's quite easy to work it out. So in the instance here, what we've got are two sites of a beach, okay, and actually what we're looking at here is a spit. Okay, so the spit is here. We've got site X, which is here, and we have site Y, and we have two sets of data. So we have site X here is there, and site Y's data is there. And what we've got is this process of longshore drift. Now that will transport material from the west all the way along to the east end of the beach. And as that material is being transported, it's being taken out to sea, bumped along on the beach, smashed into other pebbles through attrition, and the sand is causing abrasion, which makes the pebbles smaller and more rounded. And we can tell that by the data here. Now, the first problem we have is that the data set is not big enough to do a successful pebble survey. You can't just take 7 pebbles and work them out. You need different sets on different parts of the beach and look for trends and averages. Now, when this came up in the exam last year, the students were asked to work out the mean average for site X and the mean average for site Y. So we're going to do that first of all and see if there's any comparisons here, and then we'll start to talk about why the mean is potentially not the best way to look at the average size here. So the first thing I want you to do is get a calculator or your phone, and we're going to work out the means together. When I say so, pause the video, get yourself sorted out, restart it again, and we'll work that out together. Okay, so if you pause the video now. Okay, so for site X, we should have the following calculations. So you do 10 plus 8 plus 9 plus 10 plus 11 plus 15 plus 13, and that gives you a score of 76. Where's my pen? Here it is. Okay. So that gives us a score of 76, and you divide that by 7 because there are 7 sets of data. So divide that by 7, and that comes up with a score of 10.85. To 1 decimal point, I'm going to round that up to 10.9. Okay, and we're going to do the same with site Y. So we're going to do 9 plus 5 plus 3 plus 5 plus 6 plus 4 plus 2, and that gives us a score of 34. Again, divide by 7 because you've got 7 individual sets of data. So divide that by 7, and that gives us a score of 4.857. So we're going to round that up to 1 decimal point, and we're going to have 4.9. So straight away you've got your means. Now the mean average here actually confirms what we thought we would find. The pebbles are going to be bigger at site X than they are at site Y, and that's already down to attrition and erosion. Now, to work out the range, because what we actually want to see is whether the range of size of pebbles at X is similar to the range of the size of pebbles at Y. We know straight away that these are going to be smaller, but we want to see whether there is a greater range of the size within each data set. So to do that, what we need to do is we need to work out our median. And again, what we'll do with this is we're going to put the site X data in size order. So we're going to go 15, 13, 11, 10, 10, 9, 8. And we're going to do the same with site Y as well. So we're going to go with 9, 6, 5, 5, 4, 3, 2. So if you get those looked at there, and we can start to look at the range. Now, the median for each of these is 1, 2, 3, is going to be the fourth number up. That's the middle number when they're put into size order. So we've got a median of 5 and a median of 10. And the difficulty here, what straight away we find, is that we have a number which is just above. Okay, that, and that's the same one as well. So we can still know the median is 5 at this point. To find the interquartile range, we need to find the midway point between the median and the top data. Now this is where this makes it quite easy for us, because the midway point here is going to be 6 and 3, 9, 13 at this data, because we've got 1, 2, 3 to the top data there, 1, 2, 3 to top data. So we've found that our mid-range point is here. Now this is what we would call upper quartile, and this one here is the lower quartile. And effectively, to work out the interquartile range, you take the lower quartile away from the upper quartile. So for site X, we have 13 minus 9 equals 4. And for site Y, we've got 6 minus 3 equals 3. So when we start to look at the interquartile ranges, 4 and 3 isn't massively different. So what we can now tell from this data is that by using the means, we know that there's a big difference. By using the medians and then the interquartile range, we can actually tell that the variety of sizes of pebbles at site X and site Y, the range of those is very, very similar. Okay, even though the pebbles at X are much bigger, we know that the range in size is very similar to site Y. Now for a geographer, that would actually tell us that the rates of erosion are pretty consistent in both areas and not accelerated at another point. So for example, if we found that the interquartile range at X was 11 and at the interquartile range at Y was 3 still, that would tell us that erosion is very, very fast at Y compared to the rate of erosion at X, because the range of pebbles is much, much greater. Okay, thank you very much.